Hello, friend. My name is Derek Harder, and in this video, we're going to continue looking at customizing Keras, so getting into a little bit of the deeper of the internals of it. Just a quick look. So previously, we saw that using callbacks and then maybe overriding, subclassing a metric or callback could give you some more power to get into the training loop and do more things with it. So we're going to carry that one step further with a few quick examples here of how you can actually write your own training loop and what you might be able to do with that real quickly. So let's go ahead and get started. So just as a quick reminder, the content of a typical training loop that we've looked at in this class so far looks something like this. So you run a forward pass, that is, you compute the model's outputs by doing all the tensor transformations from the input through the various layers to the output. So for, when we're using TensorFlow, we'll do that inside of a gradient tape context. So it can build a computation graph of the operations that are being performed, so that we can obtain a loss value. But the forward pass can, obtains calculates the output, and the gradient tape, creates a graph, and it also can be used to obtain the loss value for the current batch of data. Okay. And so then we use that gradient tape to retrieve the gradients of the loss with regard to the model's weights at the various layers of our model. And then we update the model's weights so as to lower the loss value on the current batch of data. Right? And we iterate that as many times, as many batches, and as many epochs as needed. Okay, this is essentially what the fit method does for you under the hood. So in this section, we're going to look at re-implementing fit from scratch. So if it's needed, we can add bells and whistles or implement any kind of specialized training algorithm that you might need. So one quick note to keep in mind. So some layers, such as dropout, have different behaviors during training and inference. So what that means is that we have to, at various places, we have to indicate whether we're doing training, so whether we're in the fitness function, or if we're done training and we're doing evaluation. So that means, for example, when we're computing the forward pass, we have to pass in the training as true flag. And in addition, so there's also this difference that we've discussed before between trainable weights and non-trainable weights. So we have to make certain that we use the trainable weights where needed. So to refine a little bit what we talked about before, the pseudocode for an individual training step might look something like this. So within the context of a gradient tape, we perform the forward pass doing this. And since we're trained, we're going to set train equal to true, compute our loss function from the predictions and the targets that we had, and then calculate the gradients on only the trainable weights using TensorFlow's tape, and then apply those gradients to the trainable weights. So also a note, we don't have to write everything from scratch. So even if we're creating our own training loop here, so we probably want to make use of metrics that already exist. So if you want to use a metric as an example, the sparse categorical accuracy here, if you give it like your targets and predictions, if you just call update state on it, that will update the state of the metric on the targets and predictions, and then you can call result to get the result. So in this case, the metric currently result given these targets and predictions has a value of 1. Or another quick example of a metric, so we could use like the mean metric, where just a bunch of values are happening, and then you can then by calling the result of that, it'll calculate the mean for you. Right? So the mean of those values is 2. And don't forget, there's another method you need to call reset state at the start of an epoch if you need to reset the results, so gather them again. So often at like the beginning of an epoch or something, you might need to call this reset state here. So putting that all together as an actual example that works, we're going to actually just, not use fit, but we're going to write our own training loop. All right. So we're using some metrics, kind of like I was talking about before here inside of this. But so this is supposed to be called every time for a batch. Okay. So within an epoch, multiple training steps will be called, and we'll give a batch of inputs and the targets for that batch. Right. So these are what we discussed actually right here. So within the context of a gradient tape, we calculate the forward pass for our model. All right. So we've got a whole model here. So this is going to give us the full forward pass. And since that's within the context of this gradient tape, even if there's multiple layers here, this is building the computation graph of everything that happens inside that model. Once we have the predictions, we can calculate our loss using whatever the loss function is. So we're just using sparse categorical cross entropy here in this example. We have our tape now, so we can get the gradients with respect to the trainable weights for our loss. And then we can apply those gradients for our optimizer using RMS prop here. All right. And then the rest of this is just updating the metrics. So we're using some of our metrics that we talked about to update their state for each training step here. And at the start of an epoch, so that this training step is going to be called multiple times for an epoch. So at the very start of an epoch, we need to reset the state of some of our metrics. Okay. So with those, we're basically re-implementing the fit method here in our own loop, so that we get batches here. So we're using a little function from TensorFlow that actually creates batches for us, the batch size 32 in this example. So this will get batches, call the train step on a single batch, and then so do that for all the batches. That represents one epoch, and then we'll do that for whatever number of epochs we want to do of training. So 3 in this case, right? So this is kind of really just a re-implementation of the fit method, but we've done it by hand. Step that we need to do. Okay. One thing you'll notice, so I'll let this run, but if you run this yourself, you'll notice that it actually seems quite a bit slower than you might be used to. Okay, so let's let that run to completion. Okay, and then we're finally done with the fitness here, so that will take longer than usual. You'll notice. Notice, so the metrics that we're using, we have accuracy and loss. So at the end of epochs, we're reporting those again. So just to complete this example, after you've done training, you might want to evaluate. So you call the evaluate function. So the evaluate is really the same as doing the fit. It's just that, we're not training anymore. So training becomes false. And we omit the steps where we calculate the gradients and update the weights. Okay. So, but most of the other stuff in the test step here is similar to what was happening in our train step up here, although just omitting some parts of this for updating the weights. Okay, so let's go ahead and do our evaluation. Okay, and our evaluation is finished finally. So as we mentioned, you might notice it's running significantly slower, and that's because by default, we've mentioned this before, that TensorFlow is going to be executing code eagerly, line by line. So it's kind of like we're running it an interpreted language, so an interpreted mode. Okay. So, but we can, get that speed to what we would expect by compiling the computation graph. So, to do that, we just simply need to add in what these things are known as decorators. So this is some extra information which will cause it so that the functions that we need will actually get compiled instead of running it in this eagerly in this interpreted mode. Okay. So if you try that out, you will notice we're doing the same thing, but we use that decorator for our test step, and we run our training loop again, so or evaluation loop again. But let's try it again. Now that I looked at that a little bit closer, while it probably sped up the test step, but it would probably be easier to see that it's actually working, speeding up if we did it on the training. The train step, and over a couple of epochs of training using the train step. So let's, instead of as the textbook did, where it just compiled this with the decorator for the test step, let's try it out again where we do it with the train step and redo the 3 epochs of training here, okay? So we'll start off. Okay, and there's done. So you should, I mean, it still felt a little bit slower than usual, but significantly faster than when it's running in the interpreter mode. So those do what they're saying there if you use those. So implementing a training loop completely from scratch is a bit extreme. There is kind of a middle ground. So you can actually just override that train step method. So you can create a subclass of the model, and one of the methods that's called in a model is the train step. So in that way, you can reuse everything from fit, except just have your own train step called instead of the built-in one. So as a quick example here, we've seen example before of subclassing from the Keras model base class. In this case, we're just going to have our own train step, doing a similar thing to what we did before. So this will get called in the individual batches when we're doing fit, okay? So that means that we can basically, if we just use our custom model, so our custom model, we're building it using the functional interface here, but we give it the inputs and the outputs, and then we can do our normal, pretty much our normal workflow. So instead of using a model, we use our custom model so that it will be calling our own train step when we do our training using fit here. Some notes on this. There was a couple typos in the textbook, so this needs to really be self-trainable weights and self-optimizer. So that was wrong in the textbook. And we're done with training on, okay? Okay, and one or 2 points about the previous example. For one, you don't need the decorator anymore, because any subclass or the methods of a subclass of model, it knows that those really need to be compiled like the train step. But yeah, notice, I mean, we could reuse the functional API, or we could have used the sequential model, but we weren't doing things like, for example, we weren't using. We're just using like a hand-coded loss function and other stuff in this example here, right? So what if we want to more tightly integrate with Keras? So after the compile, we can have access to the loss that was asked for in the compile function and the metrics and things like that. So you can actually use those. So we didn't have to have an external like loss function or metrics. So here we've just, again, modified, but we're using the loss that's given to the compile function and so on, right? So I probably should have pointed that out before. So when I compiled before, we only specified the optimizer. So now we're specifying everything again. The optimizer, but the loss function and the metrics, right? So then that works in this last example. Okay, so that's it for this video. Hope that was helpful for you. So you may not use that kind of stuff very often, but it's good to know that exists. You can get right down to kind of detailed stuff if you need to build your own training loop or get into it in order to modify things while they're happening. So, but it is good to remember that the content of a typical training loop is to run the forward pass on a batch inside of a gradient tape to obtain the loss. From that, we can retrieve the gradients of the loss with respect to the model's weights. And that kind of happens automatically for you if you do that in the context of a TensorFlow tape for all the layers of a model, right? And then, we update the weights to lower the loss on the current batch of data when we have the gradient. So, and kind of that last example, so a good sort of middle ground, if you need to do something special, is to create a custom model. So subclass the model class and override the train step if you need to get in there. Okay? So that's it for that video. I hope that this stuff is useful for you, and I hope you'll join me for the next video. See you later.